Good evening, all of you.
Good evening, sir.
Good evening, sir.
Good evening, sir.
सर आप पहले असाइनमेंट ले सकते हो असाइनमेंट के डाउट्स
Whatever you people say.
Sir, can we go by majority?
Sir, assignments objectives are not yet.
Sir, those aren't done, but objectives are done.
50
Has only
sums,
objective done.
48 या 50 sums that of objective.
I am okay either way. We just do the voting. Wait for 1 or 2 more minutes. Let others also join. We will vote
So this
accordingly.
was the maximum strength.
Okay. Now, people who want me to take the assignment doubts right now, please raise your hands. Assignment doubts जिसको चाहिए, please raise your hands.
Sir, objectives, right?
Objectives. You are in the majority. 47.
There are only 47 students.
27 have raised their hands. People
So that
have
happens every time.
You know what for you raised your hands, right?
Yes, sir.
Yes,
Assignment out.
Objective. Now, out of my curiosity, you people haven't yet completed the attempt of the subjective questions of
Yes,
the
sir.
assignment.
Yes, sir.
Yes.
Yes, sir. Not fully.
तो एक सेकंड रुको, असाइनमेंट खोलूंगा.
Sir, हर डाउट लेक्चर में ऐसे ही होता है. The attendance has never crossed 50 in a long time.
Except that lecture you.
That's actually the most dangerous part. I completing the syllabus is not a priority. You completing the syllabus is a priority. Now, students who don't complete, don't attend the doubt lecture. They have not completed their homework. So, for them, attending the doubt lecture doesn't make sense. That's the most dangerous part. That's where the fall starts for a student. This is something that n number of times we explain to the kids, but somehow they fail to realize this. It's a blunder committed by them. But क्या बोलेंगे? बोलो. Assignment 3 objectives.
Sir, ninth question, first 4 parts.
So question 4.
Sir, 40.
1 4 or 4 0?
4-0.
Sir, 23.
Sir, 43.
27.
Sir,
So
44.
26. So 26.
43.
So 37. So 47.
40.
40 ऊपर दिख रहा है ना.
Oh, sorry.
Sir, 45 also. 45. And so 50.
1 5 or 5 0?
50. 50.
Firstly, fourth question. Block of mass 1 kg. This is a string. This is the block. A 2 kg है. The bullet is being fired 0.25 kg with a velocity of u. U का value दिया हुआ है.
Yes, sir. 200 meters per second.
U is 200 meters per second. Right? Bullet penetrates through the block A and comes out with a velocity of 100 meters per second. So technically, if I draw the free body diagram of the bullet, initial velocity is 200, final velocity is 100. So on the bullet, there was an impulse J in this direction. Do you agree with that?
Yes,
Yes,
sir.
sir.
Yes, sir.
I take everything in this direction positive, everything in this direction negative. So J is equal to final momentum of the bullet is negative of 0.25 into 100 minus initial momentum of the bullet is minus of 0.25 into 200. Final momentum, initial momentum, both are in the negative direction. I know J is towards the right. ये किसने बता दिया आपको कि बुलेट पर impulse is in the backward direction? भाई साहब मोमेंटम कम होते जा रहा है इस डायरेक्शन में. So impulse will be in this direction. This will be minus 25 plus. How much is this? 50?
Yes, sir.
Yes.
So 25 Newton second is the impulse on the bullet in the backward direction. Equal and opposite impulse on the 1 kg block will be in the forward direction. Free body diagram of the 1 kg block is the reaction of this J and T delta T. These are the two impulses acting on the 1 kg block. Do you agree with that?
Yes, sir.
Yes, sir.
डायरेक्शन ऑफ द इंपल्स कैसा पता चल गया यार आपको? न्यूटन्स थर्ड लॉ, एक्शन रिएक्शन, एक्शन ऑन द बुलेट, रिएक्शन ऑन द ब्लॉक. J minus T delta T is 1 kg into V. 1 kg into V. By the way, J is how much? 25 minus T delta T is 1 into V. This is my first equation. Same T delta T will be 2 into V. We have two equations and two variables. T delta T is one variable. V is the other variable.
So second equation from string constraints, right?
T delta T, the same tension will be all through.
Yes, sir. Yes.
T delta T will be the same. Now, why did you take the same velocity speed for both? Because of string
String
constraints.
constraints. Yes, sir.
Third doubt which I expect you people to ask. भाई साहब on 2 kg block upward impulse ले लिया, mg क्यों नहीं लिया भाई साहब आपने?
Non-impulsive.
Non-impulsive.
Force will never be balanced by a
Non-impulsive.
Non-impulsive.
very.
So can you also add 34?
थोड़ा खर्चा होगा, थोड़ा खर्चा होगा. लेट बताया.
सर एक
Sir,
बिटकॉइन.
Bitcoin.
Sorry.
एक बिटकॉइन.
एक डाउट के लिए बेचारा लुट जाएगा.
छोड़ के चला जाएगा. एक बिटकॉइन एक डाउट के लिए.
सर अभी तो रिग्रेट हो रहा है सर, पैनेशिया बेटर साइट्स आए नए साइट्स.
हाँ सर, पेनेसिया बहुत
यार मुझे भी वो फीडबैक मिला कि a new site is not up to the mark. I conveyed the feedback to the tech team. Let's see. Tomorrow will be a pain for us. Seniors भी एग्जाम ले रहे हैं. पता नहीं tomorrow.
सर
So
मैंने
the
वो
user interface isn't as friendly as Panacea.
But Panacea में there are certain bugs now which has gone beyond repair. So there they are unable to make the changes. The new system they will have to. पता नहीं पूरा tech team जाकर they are only on one thing. I don't understand why they.
Panacea में actually even if they just give us instant results, like the minute the test is over, give us the result, we are fine with it, sir. That and a rank list, a proper non-bug rank list.
So, but
You
the
don't need a
result
website.
generated is wrong.
One second. Present website, the like before your batch, I had a doubt lecture with the flagship batch. They gave certain feedbacks. What was the negative that you people feel in the present new website?
Sir, it hangs a lot. It takes a long time to load.
And clear response is not there, the option.
Yes, sir.
The option is there of clear
Clear.
response. But
Sir, it was there.
It was
So it
there.
was there.
it was there, sir. Clear response.
Okay, so I think some problem will be there with me.
Okay, one problem which you are telling me is it hangs a lot.
Yes, sir.
That's a lag. Lag.
The lag is more correct. Yes, sir.
Okay, that's what even they said.
So the result they are saying will come on February 14th.
Yes, sir. 19th February.
That is bad.
19 February.
The result should come instantly.
Yes, sir. So that even if
So
Panisha
daily
gives,
mails will give you your score immediately after the bits. As soon as you're coming out, you have your score with you. So that way, the result should be updated. Can I rub this?
Yes,
yes,
sir.
sir.
Yes, sir.
So that actually, even if Panisha gives it to us, that's fine with us. We don't need a new site then.
Yes, sir.
I will convey both the messages to them.
So that and a rank list, if Panisha is able to display, then that's perfect with us.
So, but the result Panisha generates is wrong. Like it's always wrong.
Yes, sir, mostly.
So Panisha gives us a rank
The
list.
analysis that they give is wrong, right?
Yeah, so the answers are wrong, then they are corrected sometimes, not corrected sometimes.
They do one very big blunder. So when there's a mistake in the question, they just cut out the question only. They
Yes,
don't
sir, they
correct the
delete the
Yes,
question
sir.
altogether.
So then there's a very big error in the rank list. Then it's not proper.
Fine. A. Ninth question, why should this be a doubt? Not fair. जिसने भी पूछा है एक बिटकॉइन लिखो हिसाब 2M, this is 2E0, this is M, this is V0. Now, first question, VA maximum. Maximum पूछा कि minimum पूछा है? VA maximum. See, this is the initial velocity with respect to center of mass. What is the velocity of center of mass? 2M into 2E0 minus
Minus
M into V.
Upon 3M.
3M. This is 4 minus 1. So I'm getting
V0.
V0 as the velocity of center of mass, right?
Yes, sir.
Yes, sir.
When will I have a maximum velocity? So velocity of A with respect to center of mass is minus V0 minus V0 minus 2V0. Velocity of B with respect to center of mass will be V0. That means with respect to center of mass, this is going with a velocity V0. This is 2V0 initially when the spring is in the unstretched position at the start. Yes or no?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Now this is moving with a velocity V0. When will A have maximum velocity with respect to ground? ध्यान से सुनिए.
Yes.
So when net force is 0 on it.
Listen, मैं कुछ और बोल रहा हूँ.
Acceleration is 0.
When will A have maximum velocity with respect to ground? Center of mass velocity is constant. Have a look at it. Velocity of A with respect to center of mass. Velocity of center of mass with respect to ground is velocity of A with respect to ground. This is constant. You are aware of it. Yes or no?
Yes.
Yes,
Yes.
sir.
Now
Yes,
you want
sir.
this to be maximum. Implies this should be maximum in the same direction as that of this. Maximum in the same direction as velocity of center of mass. That means on its way back. Now standing on the center of mass, for me both blocks are moving away. There will be an instance where there will be maximum elongation and it will be on its way back.
Yes,
Yes,
sir.
Yes, sir.
Back, will it ever have a velocity greater than 2V0?
No,
No,
sir.
No, sir.
No,
No.
sir.
Sir.
So this is the maximum velocity it will have with respect to center of mass on its way back. Why are you keen on way back? Because I don't want to subtract both. I want to add. Only if I add, A's velocity will be maximum.
Yes, sir.
Yes, sir.
Yes.
Logic understood?
Yes.
Yes, sir.
Now on its way back, without actually solving the problem, I know that somewhere down the lane, the maximum velocity will be 2V0 on its way back, because with respect to center of mass, it will go to rest and it will come back. So on
Yes.
its way back, it will
Yes,
reach
sir.
2V0 and it will decrease. So maximum velocity of A on its way back is 2V0 with respect to center of mass. So 2V0 plus V0, 3V0 will be the maximum velocity of A. Is this clear to all?
Yes,
Yes.
sir.
Yes, sir.
Yes.
Yes, sir.
Next, VA minimum. A VA minimum will be when it has maximum velocity in the opposite direction of this. when these both get subtracted. So 2 V naught and V naught, when I subtract V naught,
Yes, sir.
Yes, sir.
right?
So can you repeat what did you just say?
This equation, are you clear?
Yes, sir.
This will be maximum when these both get added up. This is constant. This will be minimum when these both get subtracted.
Yes, sir. Okay, got it.
Maximum value of A to be subtracted, the value is 2 V naught.
Yes, sir.
Subtract it from V naught.
Yes, sir. We know.
So then I'll get VA with respect to ground to be minimum. And that
Yes,
will
sir.
be V naught.
Yeah. Thank you, sir.
Now, VB maximum, same logic apply karogi. VB maximum, V naught with respect to, this is B, velocity of B with respect to center of mass, plus velocity of center of mass with respect to ground is velocity of B with respect to ground. Maximum value of this in the same direction is V naught. This is constant V naught. So this will be 2 V naught. This will be the maximum value. Minimum value, when maximum value of B is getting subtracted,
Opposite direction.
it will be minimum.
Yes,
Opposite
sir.
direction, when it is
Yes,
coming,
sir.
that will be at rest.
Yes, sir.
Yes, sir.
What else do you need? VA is at rest, you know what to do. When will VA be at rest? When it is going in this direction, somewhere here it will acquire a velocity of V naught with respect to center of mass. At
UM.
that
Yes.
instant, VA is at.
Rest.
Yes.
Can you calculate VB?
Yes, sir.
Yes, sir.
Yes,
You
sir.
will get the velocity with respect to center of mass. Both will have the same momentum. You will get the velocity with respect to center of mass. Convert it with respect to ground.
So
Yes,
we'll
sir.
use that vector summation of wall momentum and center of mass.
Is 0.
Right. So you will get the velocity of B with respect to center of mass. Convert it with respect to ground. That is important.
Yes.
Yes, sir.
Done. Sir.
So when they were asking for VA with respect to the ground to be minimum, sir, over there, are they asking with sign or just magnitude?
That should be specified. Left side, they put a magnitude symbol. Dekho. VA maximum mod. VA
Oh, okay,
minimum
magnitude
mod.
only they are talking about.
So they will ask in the question, they'll specify. But remember, in such type of questions, I understood what you would say. You will say minus 2 V naught is lesser than minus V.
Yes.
Right?
sir.
So that the paper setter will take care of. If you take magnitude, 2 V naught is greater than V.
Yes.
Right? Paper setter will have to specify. If not, the question will go for a bonus.
So because then that will change even according to which side you take as positive and which side you take as negative.
Naturally. Now they'll have to specify that also along the positive x-axis, negative x-axis. That's why generally they'll put a mod. Which is the next question? I don't see you didn't people 23rd, I believe. क्या जंप मारा यार आप लोगों ने? 4th क्वेश्चन के बाद 9th क्वेश्चन डायरेक्ट वहां से 23rd.
सर उसके बीच में इजी था.
या सर वो 30s
हाँ, सर,
वाले
वो
क्वेश्चंस बहुत अच्छे थे सर, दिल से अच्छा फील हुआ वो करके.
I tell you about this quotation. As a rule, man is a fool.
Yes, sir.
Yes, sir.
Yes, sir. Mark
As a
Twain.
rule, man is a fool. When it is hot, he wants cool. When it is cool, he wants hot. Always wanting what is. Problem बड़ा आसान है, we become very confident. Problem थोड़ा tough है, थोड़ा depression में जाए. Human mind is very strange. Reading human mind is the toughest. Reading books is million times easier.
सर ये एक्सरसाइज 4 का सिमिलर सम है शायद
ये
आपने
आपने
करा।
क्लास में कराया था वैसे
हाँ
पर
तो
सर,
सिमिलर है सर.
1 kg सर, बाद में मोमेंटम
Sir, इसमें भी also if you do that clockwise, anti-clockwise, you get the answer in one step. But
Yes, here we'll get this. I am also aware of. You conserve momentum in this direction or in this direction, you will get the answer.
yes, sir.
That I am aware of. Quite a few people in quota ask you to do that. I would prefer to go from the concept here because that doesn't save too much of a time. Agreed that it is slightly shorter. Right? But I'll teach that also. Wait a minute. But first let us finish this. System of two blocks A and B are connected by an inextensible massless string as shown. The pulley is massless and frictionless. Initially, system is at rest when a bullet of mass and moving with a velocity U as shown in the hits the block B and gets embedded in impulse imparted by tension force on the block of mass 3. See, moving with a velocity of U. Right? This gets embedded into it. So first of all, conserve linear momentum between the two. It gets embedded into it. Now have a look at it. You will have T delta T here. T delta T and mu is in the downward direction. M is moving in the downward direction U. Fine. It sticks to this. These both together should be moving with a velocity, but T delta T will oppose it. So I will take everything in the upward direction as positive. T delta T, it's in the upward direction, will be equal to 2m into V minus m into U. Final momentum of the system is 2m, will move with a velocity of V. Initial momentum of the system is mu. But listen, this is also in the downward direction. This is also in the downward direction. So I'll have to put a negative sign in front of this and negative sign in front of this because I took this to be positive. Final momentum is in the downward direction. Initial momentum is in the downward direction. So T delta T is equal to mu minus 2m into V. My first equation. All of you clear with this?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Now, the same T delta T will make 3m move with the same velocity V. This is my second equation. So, two straight, simple second equations. Substitute this V here. I will get T delta T, which is asked, if I am right. Isn't it?
Yes.
Yes, sir.
Yes, sir.
Impulse imparted by tension on the block 3m. My requirement is T delta T. Find V from there and substitute, I get the answer. Or subtract both, eliminate T delta T, find V and substitute V here. However you do, I'm okay. It's quite a simple thing. So better keep this and this free body diagram separately, there will be better clarity. This T delta T is the impulse in the upward direction. Final momentum of both is in the downward direction. Initial momentum of both is in the downward direction. Initial momentum of small m is 0.
So, what was that clockwise method someone else was saying?
What they do is they conserve linear momentum all throughout in this direction. What they write here is mu is the initial momentum. Final momentum of this is 2m into V plus this is 3m into V. This will rise up with a velocity V. Together this is going down with a velocity V.
Yes, sir.
So total momentum in this direction. Simplify these both. That is what you will get.
Yes, sir.
So I have a question.
Hmm.
So when we are conserving it in this clockwise direction, over there the normal forces by the pulley on the road, like the pulley ka the stand on the pulley and all that won't come into play.
One. You are taking only the string with the two masses.
Okay, sir. So लेकिन फिर string पे भी तो force act करेगा ना pulley का normal force.
हाँ. Provided you give mass to the string.
Oh, अच्छा, okay, sir. Understood.
Tell me when I can rub the board.
Yes,
So
sir.
you can rub, sir.
Yes, sir.
$26.
Sir, don't solve this sum. Sir, I got B only, but sir, I think they forgot 2MU, sir. They forgot the U
Yes,
in
sir.
the
Now they're
answer.
printing.
Yes, sir.
only.
Yes, sir.
So might be
Yes,
printing
sir.
error.
B for Bombay, right?
Yes,
Yes,
sir.
sir.
But they forgot the
Yeah.
U.
26, the B is the answer. The answer is 2MU into U plus V. If not, the
Yes,
answer will be dimensionally also wrong.
Yes, sir.
Work
Yes.
done
Yes, sir.
पूछेगा है. Work done पूछेगा तो obviously 2M into V is not work done, it's momentum.
MV
Right.
square.
So 26th B is the answer. There is a misprint or U is missing. All of you must have got this.
Yes, sir.
Yes, sir.
Sir, in these questions, I solved it by going into the frame of the body and then again coming back into ground frame.
Yes,
Like
sir.
that
He's
also.
doing it like the ray optics method that we do to find
Yes,
speed
sir.
of image and speed of object.
Ray optics.
If you are comfortable with that, I am okay. But I will opt for a shortcut only if it simplifies my job to a much greater extent. ये तो
Yes, sir. बहुत
प्रोसीजर
simplified.
और उसमें कुछ ज्यादा फर्क तो है ही नहीं. आधा एक सेकंड के लिए I would prefer the traditional procedure. हालांकि what you are telling is perfectly okay. There is nothing wrong in using the concept of ray optics. Even in the 25th problem, you can use that.
Yes, sir. So even in that
Yes,
Super
sir.
Bowl wala problem.
Super ball wala.
Super ball is the one which I showed to you. Walter Levin demonstrated.
Yes, sir.
Yes.
Yes, sir.
27. People who solved it, tell me how did you solve?
Sir, कितना आसान है और
नहीं.
distance is equal to time.
ये हुआ सर ये.
बहुत
E
easy.
equal to 2R लेके उसको L minus D करना.
हाँ sir.
तो
minus
length is equal to L minus D. फिर
All of you are.
Sir, all the methods are wrong.
times distance.
By chance, you are getting the correct answer, but what you have done is wrong. एक second सोचो. Read the question properly. हमने क्लास में एक प्रॉब्लम वर्टिकली फॉलिंग बॉडी के लिए की. एवरेज फोर्स.
Yes,
Yes,
sir.
sir.
Yes,
The
sir.
routine question.
आप लोगों ने यहाँ एक कोलिजन से खत्म कर दिया. एन कोलिजन्स लेना है कि नहीं आपको?
Yes, sir.
क्यों नहीं लिया? It is a mere coincidence that you will get the answer even if you deal for only one collision. आपको एक एग्जांपल दूंगा, ये प्रॉब्लम सॉल्व नहीं करूंगा. ध्यान से सुनिए, concentrate and focus. Let me resolve the problem which I solved in the class. This falls from a height of h. It strikes with a velocity of under root 2gh. इसका आंसर याद है आपको? फोर्स एवरेज कितना आया था?
MV?
mg.
Yes, MG.
yes.
mg रूड़की का 4 साल का सीक्वेंस पढ़ा है ना यार?
Yes, sir.
हाँ
Yes.
Yes,
sir.
sir.
Yes.
याद
mg answer, right? Now, after it collides, it will rise with e times under root 2gh.
yes.
Yes, sir.
आपने एक कोलिजन के लिए ऊपर जाकर नीचे आने का डेल्टा पी ले लिया आपने. डेल्टा पी इज m.
हाँ सर यही किया.
डेल्टा पी m into e times under root 2gh minus of minus plus m into root over of 2gh divided by time taken for it to go up 2u by g. यही तो किए थे हमने.
Yes, sir.
EU by G. Am I right? Am I missing
हाँ,
something? जी नहीं, दो चीज एक ही स्टेप में कर दिया. Change in momentum. It strikes with a velocity u. It will go up and come back with a velocity e times under root 2gh. Fine. Now, what did you do here? Originally, delta P is delta P1 m under root 2gh e times minus of minus means under root 2gh. This will be m under root 2gh into 1 plus e. Is this what we got?
Yes, sir.
Yes.
Or I should take this. Delta t is 2 times e under root 2gh by g. 2e under root 2h by g. I am committing a mistake somewhere.
सर बट जरूरत नहीं है रूट 2gh की सर. v लेके भी इजी हो रहा है क्योंकि टर्म्स भी v में ही.
Maybe that was my mistake. Wait. I'll do this as delta p is equal to m eu I'm
सर
losing.
क्योंकि
Not
सर
concentrating. Wait.
मोमेंटम सर 2mv आ रहा है.
Someone like I'll solve this problem only. Going back into that, I want to finish it off in one step. I'm going on. यही problem ले लेंगे. 27th बोल रहे थे ना. This is the surface. When you are asking me for average force, how will you take for one single collision?
हाँ सर.
No,
Not
we can't.
practical, right? I was trying to show you the reverse calculation for that vertically falling body, but it's okay. Now I am losing track of it. So let me solve for this one. Right? He asked for average force. So once it will strike with a velocity of u, it will come back with a velocity of eu, but e is equal to 1. So delta p will be how much?
2mu.
2 times
2u,
mu.
2mu.
Every time it collides, the change in momentum is 2 times mu. So for n collisions, I should add 2 times mu, 2 times mu, 2 times mu. How many times should I add?
And times.
Now delta t is the time taken, just as in that falling problem, you have taken the time taken for it to go up and come down.
Yes, sir.
Yes.
Now here time taken for it to go and come back.
L minus d by
L minus d by v. But with
into 2.
times, because it should go and come back.
Yes,
Yes.
sir.
How many times is it going and coming?
And
N
time.
times.
Now
Try.
divide both.
Yes.
You cannot do it for one. You have to do it for n number. If he gives you for average force, you have to do it this way. It is a mere coincidence that here n gets cancelled out and you people get the answer because you saw the answer before solving the problem. Am I right?
Sir.
No, sir.
नहीं सर.
सर
But
होता
then
कैसे?
average जब पूछा आपने एक ही collision में कैसा खत्म
सर
किया?
एवरेज पढ़ा ही नहीं सर. डायरेक्टली
हाँ,
मतलब
बिना क्वेश्चन पढ़े आपको बाय चांस आंसर आ गया तो नेगेटिव मार्क आना चाहिए. काटो एक एक मार्क. काटो एक एक मार्क.
सर 5 मार्क.
हाँ. +3 - 1. So 4
No,
marks.
+4 - 1.
+4 - 1. 5 mark काटो. Now what I was trying to show you in the previous one is when you drop to the body, वहां भी एक collision के लिए consider the force and you will get mg. The same thing which you are considering here. Somewhere I am committing a mistake there. So I thought, okay, let's not waste time and get over with this. But remember, he asked for average force. Whenever he is asking for average force, please do take for n number of
N
collisions.
collisions.
सर आपको पता है सबसे ज्यादा डर लगता है जब एक मल्टीपल करेक्ट वाला क्वेश्चन होता है और उसमें बस एक ही आंसर आ रहा है हमारा.
Multiple correct में score करना for everyone it is difficult. All 4 bits you will have to read 3 times, 4 times to be sure. That's why we tell them We tell the students to keep it pending till the last. Multiple choice, multiple correct options, always
सर बट
solving
बहुत
correct.
रेयर सर, जब भी बहुत रेयर ABCD ऑप्शन करेक्ट रहता है तो बहुत मजा आता है उसमें, मतलब
हाँ, ABCD ऑप्शन सॉल्व करने के लिए टाइम भी उतना ही जाता है.
सर नहीं सर, मतलब 2 ऑप्शन भी
Sir?
करेक्ट हो जाए तो भी मतलब रिस्क तो 0%.
हाँ बोलो.
Sir, in that question, if E wasn't 1, then N and N wouldn't be cancelled, right?
And then N will be considered. Infinite series summation आएगा. Just as you
Yes,
dropped the
sir.
body and you did that.
Yes, sir.
34. Two balls of mass M1 and M2 are separated from each other by a power charge placed between them. Hey, wait, which question am I reading? One second. So, first of all, you can write M1 U1 equal to M2 U2. 34 कर रहा हूँ. सुनिए. Yes or no? M1 U1 is equal
Yes,
to
sir.
M2 U2.
Friction is non.
Because conservation of linear momentum.
Yes, sir.
Yes.
Friction is non-impulsive.
V square is equal to U square minus 2as. Final velocity should be 0. Right? U square minus 2 mu g into s. Mu g is frictional deceleration. So U will be equal to, this will be technically negative, right? Because it comes to rest, V square minus U square, this will be root over of 2 mu g into s. Don't carry the negative sign inside the square root, right? Right? Obviously, when it goes to the other side, it becomes positive. Yes or no?
Yes, sir.
Yes, sir.
M1, I'll substitute here root over of 2 mu g s1. M2, root over of 2 mu g s2. Am I right? Mu g is the same for both. S2 is equal to M1 square by M2 square Am I right?
So
Yes, sir.
Sounds simple, right?
Yes, sir. Done, sir.
So when we give the JE exam, does the result come instantaneously?
Many JEE mains में what they do is they'll release the key because there are multiple papers.
Yes,
They'll
sir.
release the key after 10 days. You can contest wrong questions. They'll give you 3-4 days time for contesting. After the contest is over, they'll release the final key and then the result.
And so same for advanced?
Advanced are also same.
Okay, sir.
Done, sir.
Thirty-seven. Sphere makes perfectly elastic oblique collision with another identical sphere. This is the easiest question. Have a look at it. This is U. Just before collision, its velocity is U cos theta and U sin theta. Do you agree with that? Say something.
Yes, sir.
Yes,
sir.
Now both masses are identical. So along the common normal, they will interchange their velocities if it is a perfectly elastic collision. So after collision, this will have a velocity of U sin theta and this will have a velocity of U cos theta. Don't you think they're moving perpendicular to each other?
Yes, sir.
Yes.
Yes, sir.
40 है. Ball moving translationally collide elastically with another stationary identical ball at the moment of impact. Angle between the straight line passing through the center of the balls and the direction of the initial velocity makes an angle of phi. Initial velocity and this angle phi. यही तो बोल रहे हो आप? Identical masses.
Yes, sir.
At the point of maximum deformation, both will have the same velocity v along the common normal. Agreed?
Yes,
At
sir.
the point of maximum deformation or potential energy पूछ रहा है. At the point of maximum deformation, both of them will have the same velocity v along the common normal before they get separated. I'll draw the diagram again. Now this is at rest. Now what happens is there is maximum deformation. This u sin phi will remain as it is, which I am not interested in. This will have a velocity v, this will have two bodies with a spring in between. At maximum compression, both will have the same velocity.
Yes, sir.
At maximum deformation, both of them will have the same velocity. Initial momentum is mu cos phi. Final momentum is mv plus mv along the common norm. So far, so good. Yes or no? Half
Yes,
and now u sin phi I will not take in conservation of energy. Why? Initial and final, dono sides I will have the same expression. Half m u cos phi I take as initial kinetic energy. Final is half mv square plus half mv square. क्या चीटिंग कर रहे हो यार? ये एक्सप्रेशन लिया क्यों नहीं आपने? ले लो ना यार, यहाँ भी लिखो, कैंसिल कर लो. फर्क पड़ेगा मुझे? Less
No,
of
sir.
potential energy at maximum deformation. Potential energy at maximum deformation. Agree? फर्स्ट इक्वेशन से आप v कैलकुलेट कर लो. v इज इक्वल टू u cos phi by 2. यहाँ पर सब्स्टिट्यूट कर लो. हाफ हाफ हाफ. I'll multiply this with 2. m. I'll divide by m. So what am I getting? U square cos square phi is 2v square. U square cos square phi by 2 whole square. 2v square plus 2u maximum by m. I don't need to help you beyond this. Required fraction is u maximum by half m u square. Right? Divide all throughout by u square. Divide all throughout by u square. U maximum by half m u square ही तो पूछा है उसने. V is u cos phi by 2, right? Why did I take u square cos square? U cos phi by 2. Are you people are also sleeping? V is u cos phi by 2 whole square. U square and u square I will bring it to the denominator. Right? I divided all throughout by u square. यहीं पर कर रहा हूं मैं. Right? Bring this 2 to the denominator. यही तो फ्रैक्शन आपसे पूछा जा रहा है. Yes or no?
Yes, sir.
Yes, sir.
Take this to the left, that will be your answer. This will be cos square phi minus, this is 4, this is 2. So cos square phi by 2 is equal to u maximum by half m u square. Sounds good?
Yes, sir.
yes, sir.
Cheap tricks, well played.
सर तो अगर ऐसे मटेरियल का k वैल्यू दिया है, then we'll even be able to find what the maximum deformation is now.
Naturally, elastic potential energy of that material, if it is given k value, rather effectively k.
So this happens instantaneously, right? Because normally we don't consider them to be moving in the same direction with velocity.
Normally we do consider. भाई साहब, small e का derivation याद करो. You took two masses and then at one
Impulse of
instant
deformation
at
upon
one
impulse of
delta t they were moving with common velocity. याद आ रहा है?
Ah, yes, sir.
Yes.
And then we took v1 v2 separately. So at the point of maximum deformation, both the masses will be moving with the same velocity along the common normal. We have done this for head-on collision. In the assignment we gave for oblique collision.
So after separation, potential energy will be maximum, right?
Come again?
After collision, after separation, the potential energy will be maximum, right? Sorry, after collision.
After collision, potential energy कहाँ होगा? After collision, they will get separated. There is no potential energy. अरे भाई साहब, collision ऐसा देखो. This is one mass. This is one mass. This is moving with a velocity. They collide. At maximum compression, both
Yes,
are moving
sir.
with the same speed. उसके बाद जब separate हो गया तो there is no compression in the spring only. During, आप लोग small e का derivation भूल गए यार. This is u1, this is u2. When they are in
V
contact,
common, V
both are
common.
moving with common velocity. Then I took this m1, m2 moving with velocity v1 and v2. ये situation पूछा जा रहा है oblique collision. Here, didn't you take both moving with the same velocity? Can I rub the board?
Yes, sir. Yes.
ये 43rd थोड़ा ध्यान से सुनिए, थोड़ा लंबा है. This is capital M, this is small m. Small m is 1 kg, capital M is 2 kg. At this instant, it is maximum compression. क्यों भाई साहब? क्वेश्चन में तो नहीं बताया उसने कि मैक्सिमम कंप्रेशन है. आपने एज्यूम कर लिया कि दिस इज मैक्सिमम कंप्रेशन. क्यों?
सर स्ट्रिंग से बांधा हुआ है.
Both with same velocity.
When does maximum compression be? When both of them are moving with same?
Oh yes, sir.
Velocity.
Yes, velocity.
And he gave you in the question that whole of the system is moving with the same velocity. I'll put it the other way now. If I am standing on the center of mass, when will I have maximum velocity compression? When both the blocks are at
Rest.
Rest.
initial state. Generally, till now, the problems which I dealt with, maximum compression comes somewhere in between the problem. Here you are starting from there. You tied it to the maximum compression and you burnt the string.
सर आपने वो वीडियो दिखाया था एक बार क्लास में of that MIT professor only.
Right. He burns the string. Now listen. Here what happens is velocity of center of mass. If you calculate, you will get 1 meter per second. Right? Obviously, all are moving with 1 meter per second. So velocity of A and B, which is A? This is A and B. Velocity of A with respect to center of mass His velocity of B with respect to center of mass is 0. When velocity of A and B with respect to center of mass is 0, it is either maximum compression or maximum
Elongation.
So right now you are at which situation? I am at maximum compression.
Compression.
Right?
Yes, sir.
Now, थोड़ा ध्यान से सुनिए, एनालिसिस थोड़ा लंबा है, it will take it all. एक सेकंड में अगर समझ में आ गया तो you are done with it. That's the beauty. What did you say in a similar problem previous to this? Velocity of A with respect to center of mass plus velocity of center of mass with respect to ground. I'll get velocity of A with respect to
Ground.
When will I have B having maximum velocity with respect to ground?
So when its velocity is maximum in that same right direction, in the direction of the center of mass.
Right. First of all, I should have maximum velocity with respect to center of mass in the same direction.
In that direction,
Yes,
yes,
sir.
so that they add up.
What happens when that's a natural length?
Oh, yes, sir. Yes, sir. Yes.
Yes.
This is capital M. This comes to natural length. This is small m. So at natural length, whatever velocity of B with respect to center of mass aega, this should be the natural length. Tabhi, if I know this velocity, center of mass is moving with uniform velocity of 1 meter per second. This velocity plus this will be the velocity of this with respect to ground.
Yes, sir.
Yes,
Yes,
sir.
sir.
And that will be the maximum velocity.
Yes, sir.
Do you agree with that?
Yes.
Sir, can you please explain it again?
Listen. Velocity of B with respect to the ground will be maximum when its velocity with respect to center of mass is maximum and in the same direction as center of mass. Velocity of B with respect to center of mass plus velocity of center of mass with respect to ground is velocity of B with respect to ground. This should be maximum and it should be in the same direction. Agreed?
Yes.
Yes, sir.
Yes.
sir.
When will this be maximum? When spring comes to natural length?
Yes, sir.
Yes. Sir.
Yes,
Yaad karo, jab spring was at the natural length, you gave velocities and you called them maximum velocity.
Yes.
Yes or no?
Yes. Sir.
Yes.
Yes,
Yes, sir.
sir.
Yes, sir. समझ में आ रहा है.
Right? So now, I don't know how much is this velocity, but I know one thing for sure. Ye kitna bhi ho, this is m, this is 2m, right? If I take this to be v, this will be 2v. Kyun? Momentum of these two should be equal and opposite.
Yes, sir.
Yes, sir.
Yes, sir.
Agreed?
Yes.
Yes.
Yes, sir.
This is velocity with respect to center of mass. This is velocity with respect to center of mass. Fine?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Till now, all the problems I dealt with, I went from here till here. I gave you this situation and I asked you for maximum compression. Yes or no?
Yes, sir.
Yes.
Yes.
Now you are feeling it difficult because we did the reverse. From maximum compression, you are coming to the natural length, initial state of the problem. Maximum compression will be half mu VR square is equal to half kx maximum whole square.
Yes, sir.
Yes, sir.
Yes, sir.
Half mu tak aa jayega mujhe. 2 into 1 divided by 2 plus n. VR don't take between these two. These both velocities are with respect to center of mass.
Yes, sir.
VR are velocities with respect to
Ground.
Ground.
first translate this with respect to ground. With respect to ground, how much is this? 2v plus 1. This with respect to ground is how much? If it is in this direction, v minus 1. Great.
Yes.
Now these are the two velocities with respect to ground. Substitute VR. This minus this. 2v plus 1 minus of v minus 1. Minus of
So minus v. Also one
Yeah.
minus v.
हाँ सर, क्योंकि पैसा पहले ही माइनस ले लिया ना.
So why did you take v minus on the
So
left
we'll-
direction? Just write in the right direction.
Minus v plus 1. So velocity of A with respect to ground will be velocity of A with respect to center of mass plus velocity of center of mass with respect to ground minus v plus 1.
Yes, sir.
Minus v plus 1. So this is 1 minus v in this direction. 1 minus v in that direction means minus of 1 minus v. Agreed?
Yes, sir.
Yes.
Yes.
Yes, sir.
This velocity minus this velocity, this becomes minus of minus will become plus. नहीं, कुछ तो गलती किया है minus negative positive. Relative velocity of this and this, 1 minus v is towards the left, right? अरे नहीं, 1 minus v is towards the
So
right.
just add v minus 1 ना directly क्योंकि वो तो फिर पता है ना magnitudes get added whenever they are in the opposite direction.
Yes, sir.
So don't ignore the sign, sir. उसका magnitude will be v minus 1 only, right, with respect to the ground.
But we subtract 1 times 1 minus.
Then you put plus of v minus 1. Is this
Yes,
what you
sir.
tell me?
Yes, sir, because magnitudes will always be added.
Will become 2 plus 1 is 3. 2 and 2 will get cancelled. 1 by 3 into 3v whole square. 1 and minus 1 will get cancelled. Half k x maximum whole square. He gave you x maximum. 3. This will become 3v square is equal to half. What is the value of k that he gave you?
600.
600.
600. X maximum कितना दिया है?
10 centimeters.
10 centimeters.
0.1 whole square. 2, 300. 300. V is equal to 0.1. 1 by 100 plus 1 by 100. V I am getting 1. Yes or no?
Yes, sir.
Yes, sir.
This ends the game. थोड़ा ध्यान से सुनिए. What did you get? V. V is 1. This is the velocity
In
when
center.
the spring is in the natural length. Velocity with respect to center of mass. 1 and 2. Agreed?
Yes, sir.
Yes.
अब सुनिए. If this is 1, center of mass is 1. That means this block is at
Rest.
Right.
So when this attains maximum velocity, this block has come to
Rest.
Yes.
बाकी हो जाए.
Yes.
थोड़ा लंबा
Solid question
problem
था
है.
ये.
थोड़ा लंबा है. Now from v equal to 1, you realize that this is 2v, this is 2, this is 1. Both velocities are with respect to center of mass and the spring is in the natural length. But advantage of getting this v as 1 is 1 and 1 are in opposite direction. So b is at rest. I mean A is at rest when b has maximum velocity. A is at rest when B has maximum velocity. This is the most important inference. उसके बाद आप लोग कर पाओ. उसके बाद कुछ ज्यादा है नहीं. Generally, we went from here till there. Now he is asking you to come from there till here. Only one important catch. This VR is the relative velocity of the two particles with respect to ground.
Yes, sir.
That you translate and substitute, you will get. And by the way, how did you take this V and 2V? Momentum of this and this should be equal in the center of mass frame and opposite in direction.
So can we solve this using ground frame?
Comfortably. Equally lengthy होगा.
सर
Okay, sir.
उल्टा ज्यादा
All you
लेंथ
have to see in ground frame is, ultimately you have to come to this conclusion to solve. For B to have maximum velocity, A should be at rest. You are translating whole of the spring energy into kinetic energy of a.
सर ये टिपिकल एडवांस लेवल का क्वेश्चन है.
Exactly. This should actually be a subjective question. वो objective में आ गया.
सर इसमें नोट्स में ही डाल देंगे, अच्छा क्वेश्चन था ये काफी।
हाँ सर।
हाँ, quick
इसमें तो
reference
आंसर्स
भी
नहीं
काम
आते।
है।
So you can rub the board if you want, unless someone is copying.
Here from 44, I will cover in the next class here. The next class is on Saturday, right?
Yes.
Saturday from 44, we will cover the second part of this assignment. Now, do me a favor. Now, don't tell me Saturday ko 44 say we will cover till objectives and go to HCB and come back to subjectives.
सर नहीं सर
बोलो।
सर प्रतीक सर ने
नहीं सर, सैटरडे को असाइनमेंट ही कंप्लीट कर
प्रतीक सर
देंगे।
ने COM का ऑलरेडी बना रखा है तो HCV का, तो वो भी देख सकते हैं।
Right. So Saturday we'll complete the assignment. That's what I'm telling.
Yes sir.
Good, great. Saturday assignment will be over. Nothing to worry.
So do you have any tips for the TWT on COM this Sunday?
बड़ा आसान है, चिंता मगर
सर MP
बोल
के लिए
दो, चिंता मत करो का ये मतलब थोड़ी है कि that you will not touch it.
हाँ सर पढ़ेंगे सर।
पढ़ो, but it will be easy. Topic wise just won't be difficult.
सर MT के लिए COM किधर तक आ रहा है?
COM तक आएगा, एक कंजर्वेशन ऑफ मोमेंटम कोलिजंस नहीं है
सर MT में भी सर, लेकिन फिर चैप्टर में बच क्या गया?
COM यार, ये कोलिजंस चल रहा है, वो जेनेट 4-5-6 बैच में collisions अभी that batch I just started. The teacher who was taking the class for them, he's down with COVID. So I just took over that batch and I realized their collisions अभी चल रहा है. Inelastic, elastic collisions define किया हुआ है उनको. ये spring mass system तक आया ही नहीं. तो क्या देंगे हम conservation of momentum? उनके साथ अकोला का बैचेस also are merged. So उन सबका स्प्रिंग ब्लॉक सिस्टम तक आए नहीं, इंपल्सिव नॉन इंपल्सिव फोर्सेस कब तक आएंगे?
हाँ सर।
सर MT में भी बस
फिगर्स को कंसीडर करना है कि नहीं करना है?
Pardon?
सिग्निफिकेंट फिगर्स को कंसीडर करना है कि नहीं करना है MT में?
करना है. Significant figures need to be from here afterwards. The paper setters also will have to be a bit alert in giving. They generally keep forgetting to give the value of G. Significant digits they'll keep forgetting, but they will also have to take them into consideration. Significant digits must be taken into consideration.
Okay sir, thank
you. So both for the TWT and the MT, so just confirming only center of mass will be coming.
Yes.
अच्छा ठीक है सर, मजा निकल गया सर चैप्टर से।
Don't neglect this assignment. Finish off.
नहीं सर, ऐसे थोड़ा बुरा लग रहा है सर, इतना मेहनत किया और फिर बस
I understand, but there's nothing that we can do. Those sections are quite large. Janet 4, 5, 6, Akola 1, 2. That means 5 sections. They're lagging behind by 6, 7 lectures.
Sir, Akola is merged with another Safe Hands करके कोई तो.
Akola is called Safe Hands. The institute's name is Safe Hands.
Oh, so why is it not PACE?
Safe Hands and PACE. No, there are two groups there in that junior college.
Oh, acha, okay, so.
Sir, please share today's recording.
Yes, sir.
Why? Attend nahi kiya tune starting se.
So no, so we'll take screenshots then of all of the questions and then we'll document those.
It's okay. I'll send the recording.
Thank you, sir. Bye, sir.
Thank you.
Thank you,
Bye.
sir. Bye, sir. Thank you, sir. Bye. Good night, sir.
Good night.